Hello, I'm Aaron from DataStax, and today I'm going to take you through another part in evaluating your Cassandra cluster for migration to AstroDB, in which we're actually going to examine the schema and maybe some of the considerations you might have in moving like a legacy Cassandra or DSE application and migrating it to DataStax AstroDB. So let's go have a look. All right, so real quick, we're just going to talk about key spaces and maybe some things that are a little bit different about that in Astra. We're going to cover a quick point on materialized views if you're using them in Cassandra. We'll talk about storage attached indexes and have a demo on how storage attached indexes can actually supplement some of the features you might get with search engine integration with something like Solr or Elastic or OpenSearch. And of course, to show how to do this on a legacy application, we have our very own legacy application, Killer Video. It's been around for a while, and we're going to show you how to modernize it and get it ready for migration. Okay, important to note that if you went ahead and downloaded the Killer Video all-in-one and you ran it, what would happen is it would create a key space inside of an older version of DataStax Enterprise. The key space would be named Killer Video, but it would create it using the simple replication strategy, and it would create it with a replication factor of 1. These settings are simply not sufficient in terms of going forward and supporting a production application. So Simple Strategy's big problem is that it does not take multiple data centers into account. However, if you just quickly need to spin something up on your own machine and you maybe only have one node, well, Simple Strategy is not such a bad idea. Whereas Network Topology Strategy is indeed recommended for production. It does handle and recognize multiple data centers, and quite honestly, that's what you should be using for anything outside of personal development. Tell you the truth, for me, I spin up all of my local clusters on my laptop that I use for dev work with Network Topology Strategy because I like to replicate what I'm going to be using beyond my laptop as much as I can. The replication factor. Hey, you're going to want to make sure you're setting that. 3 is the most common. 3 is actually what gets set by default when you create a new key space inside of AstroDB. AstroDB will also use Network Topology Strategy by default, and it will go ahead and create your key space using the Network Topology Strategy format of data center name with replication factor pairs. So if you have multiple data centers, you'll see those data centers' names there, each with their replication factors of 3 when they are created. And just as an example, you can see that here. This is what Killer Video looks like inside of a dual data center deployment in DataStax AstroDB. So you can see that it has the network topology strategy, replication strategy, and it also has replication factors designated for US East 1 with 3 replicas and US West 1 with 3 replicas. Okay, materialized views. Important to note, AstroDB did not port those over. Materialized views never really did work as well as they were intended. Before you go to Astra, if you have an application that is using them, you'll want to redesign that approach. Usually a query table is the way to go. Specifically here, if we look at the videos table, you can see that we have videos and then we have videos by user. Sometimes you might want to be able to query videos that have been created by a specific user, and that table would allow you to do it instead of creating a materialized view based on the videos table. All right, storage attached indexes. If you've used Apache Cassandra for a while, you know about secondary indexes, you know about storage attached secondary indexes or SASE indexes. But AstroDB uses the new storage attached index recently added into both the Cassandra project, DSE, and of course DataStax AstroDB. It's important to note that storage attached indexing is what makes vector search possible. So that is, if you're looking at an application that relies on vector search or is a RAG application, retrieval augmented generation, you are definitely going to want to look at storage attached indexing. Storage attached indexing also has some cool things, like it lets you apply different tokenizers and filters that we all have specified in our documentation, but it lets you do some really cool things with, matching and searching and that kind of thing. All right, so let's go to our demo. Basically, we're going to create a storage attached index to replace a Solr search query using a tokenizer and a filter, and we're going to show you how that all works. If we have a look at Killer Video here, let's go ahead and try this out. We'll do a simple search, and I'll just type Cassandra, just like that. Okay, and as you can see, the one video shows up that is talking about building GenAI applications with Cassandra and Langflow. More importantly, though, if we slide over our Docker desktop here to have a look at the logs, you can see that, let's see here. Let's back out and maybe look at the back end. Yeah, here we go. So here's the back end. And you can see that it went for Cassandra. So each time I was adding something to that list or to that search well, it was going ahead and running a query on that. And the idea here is that right here you can see the query that ran. So basically it's doing a search inside of Solr for name, Cassandra, tags, Cassandra, description, Cassandra. So it's looking for the word Cassandra in there. So what we'll need to do is come up with a way with a storage attached index to go ahead and replicate that, and we're going to do it on the description field. So let's see if we can make that happen and get that same result back. Okay, let's go ahead and use Killer Video. I don't have this table out here right now, so let's just create it quick. So let's say create table videos, and we'll say video ID, and that's a UUID, and that's also our primary key. And then we'll say added date, and we want that to be a timestamp, and description, that's text. Location is also a text. Location type is an int. Name is a text. Preview image. Location is a text. Tags is a set of text. And user ID is a UUID. That should do it. Okay. Then we're going to need an index, a storage attached index on our description column. So let's say create custom index, and we'll say video stemming IDX on videos. Description, we want it on that column, and we'll say using storage attached index, and we'll say with options equals, and we want the index analyzer, and we're going to say tokenizer name, and the tokenizer that we want to use, it's the standard tokenizer, and then we also want to specify a filter. And you can specify multiple filters, so they come in an array. We'll have to specify a single item array with name, order stem. That's the name of the filter we want to use. And then let's cap that off, and cap that, and then one more, and a semicolon, and that should do it. Okay, great. Now we can load data. All right. We can do a CQL shell copy to the videos table, and we can do this from killervideos.csv. Oh, didn't like that at all. Let's do consistency, local quorum, and then rerun our copy. Hey, there we go. Now we have videos. Now we can do select star from videos. Perfect. Now, with that index created, I should be able to run a query like this, where I say select star from videos, where description. Oh, right. I can't use the equals operator. I need to use the indexer analyzer operator, which is the colon. And then I can say Cassandra. Let's try that. Hey, and there we go. Look at that. We got back our Cassandra video that essentially, looks at this description, and here's where it finds the word Cassandra, and it's able to go ahead and match that up. So this is one way that you can use storage attach indexing in place of functionality that may rely on internal search engines like Solr, Elastic, or OpenSearch. So in this video, we just covered some short things on examining your schema in preparation for migration to DataStax AstroDB. Again, you'll want to make sure you have a look at your key space configuration, just so you're aware of how it's going to look inside of AstroDB. Make sure you're not using materialized views, and go ahead and give storage attach indexes a look. They are definitely a way that can help you do some cool things and extend out your application in ways that really hadn't been possible before. Want more information on modernizing your self-managed Cassandra deployments? Head on out to datastax.com/modernize-apache-cassandra-workloads, and you'll find all the information you need on keeping your self-managed Cassandra cluster updated and in top running form. Thank you, and have a great day.